All right, welcome everybody. We're going to talk about Superdome X today. Okay, my name is Ken Pomeranski. I'm from Hewlett-Packard, and we're going to talk about Superdome X and Windows SQL Server together and how great they are together. Okay, so how it's going to work is I'm going to talk about Superdome X, which is really the biggest server that HP is creating right now. And I'm going to start with an overview of the architecture. Then we'll get into the architecture itself. We'll kind of dig in, we'll dig in a little bit there. And then we're going to talk about the scalability, performance, flexibility, and RAS features of the box itself. Okay, and we'll show you how it really molds really well with Windows SQL Server. And we're going to really make it really nice and show you some demos that will highlight the points. So we'll show some demonstrations which will show performance, the flexibility of the box itself, then also the RAS features of the box and how it works with Windows SQL. Then what we'll do is we'll bring up Maurice to talk about really in detail, here is how you deploy Windows SQL on Superdome X in various different use cases, which are going to be really, really good, which will show you how bring out the aspects of both Superdome X and Windows SQL to really perform the best solutions for you guys. So one thing to really note is that there's been a really big shift in the last few years related to data, okay? Because of mobile phones and the amount of data that's being created, it's incredible what's happening here, okay? And what is happening is that there is a big systems or scale up is becoming in vogue again, okay? Because you really need to actually grab the data, store it, and work it. Okay, work it. And it's becoming, because data is changing so fast, you want to store the data, you want to do analytics on the same data. You can't wait overnight, you want to do it real time, so on and so forth. We really have to create different solutions going forward. Okay, and what we want to bring to you today really is how the HP with Windows SQL Server brings forward the compute power, you know, to really handle this part of the space here. So it's really kind of the high-end scale up, 16-socket, 12 terabyte, which was shown earlier today, and really we'll talk about this. This is what we're going to go after here. So in terms of thinking compute, right? HP converts infrastructure and many different solutions and so on. The Superdome X solution is the highest end of all that stuff, okay? If you think about compute, I have got a compute server for you, okay? I got something that's really, really cool here. It is the highest end, and we'll show you how it kind of works to enable your what workloads you're doing. So some common challenges we're seeing from our customers here running Windows on x86, okay? They're doing bigger and bigger deployments, and they're worried about reliability. Okay, so reliability, may be an issue. Okay, I need more scalability. Okay, people want to do greater things with Windows SQL, and I have bigger databases and so on. Reduce operational cost. Scale out solutions becoming too complex. You actually want to bring it back in again. Like I mentioned, scale up is kind of coming back in vogue again, and just because of what it can bring you to manage the data, which we talked about. Okay, and performance. So here's the kind of things we're seeing, and so really. HP and Microsoft got together really to just on this particular system several months ago to say yes, we want to build the biggest analytics and database platform, and we're going to start with 16-socket 4 terabyte, and we're going to move to 16-socket 12 terabyte as was being mentioned today. So Windows SQL Server in Windows 16, which was mentioned, you notice the 12 terabytes limits. This is like the perfect machine for it, which we'll talk about why as we go forward here with the demonstrations and with when Maurice digs into it more. Okay, so again, kind of talk about the challenges that the customers have. This is what we're bringing to the table here with Superdome X. Okay, groundbreaking performance. Okay, so we'll demonstrate that. Okay, what is actually happening? Why is it the best? What are we doing with performance? We'll actually demonstrate that. Okay, superior uptime. The Superdome X with Windows SQL. It's actually taking x86 to the next level, okay? x86 machines in the past haven't been seen as running mission-critical workloads. We're going to show you that you can, Okay, on Superdome X with Windows SQL, this is the place you want to be running. High reliability, mainframe class, mission critical class machine. This is finally brought to x86 Windows SQL and can run the biggest of businesses. Okay, and then we will talk about some other things along the way. Again, flexibility, performance, and reliability. Okay, so starting from the top here, so what is Superdome X? Okay, Superdome X, it's a nice machine there. 16 sockets, 12 terabytes. Okay, it can go it can be less than that, but 12 terabytes. Okay, and it is partitionable. Okay, so you'll see a system right there that has 8 blades in it. Okay, so you can see them horizontal or vertically there, the 8 blades in there, and each blade has 2 sockets on it. Okay, and also 48 DIMM slots on each blade, so you can do 1.5 terabytes. So each blade is a single board computer of 2 sockets and 1.5 terabytes. And then you can gang them together using partitioning and creating what we call hard partitions. Okay, so you can either take the whole thing and make one big system where it could be 16 socket, 12 terabytes, putting one big SQL instance or multiple SQL instances, or you can break it up using hard partitioning, which we'll show you how that works in a bit. Okay. And then, of course, we have the one thing we want to know, performance, is that we just blow out performance of anything that's out there, which we'll talk about. Superdome X is an incredible machine, highly scalable, and we'll show that as we go through here on what it brings to the table here in terms of flex. So remember, it is big and bad, big and bad. That's what I like to think about it, and it's just really the best system here, and we really bring out the characteristics of what gets run on it. Okay, in SQL Server, you kind of seen some of this stuff. So we talked about the server itself. SQL Server 14 brings a lot of things to the table here, which we are bringing forward with Superdome X. We really highlight these capabilities, and then when you get to SQL Server 16, which should be coming out, we'll be even bringing more capabilities forward of where SQL wants to go, okay? Because they've seen 16 sockets, 12 terabytes, and then we'll be able to do a lot of in-memory transactions, and we'll have really, really, really good solutions, even starting from 14 here, which you can get today, and so on, customers deploying on it, and then with SQL Server 16 later on next year. And so we're really kind of building from what we're right now, what we're doing now. Okay, so thing to note is that Superdome X plus Windows SQL Server, this is what we're doing. Okay, this is what we're going after. We are laser focused on these markets right here and these purposes. Okay, the system itself and Windows SQL, this is exactly what we're going after. Okay, the biggest and best and most critical workloads. Okay, business processing and decision support. Okay, this is exactly what we're doing, and this is really what we do. Okay, and so it's really, really large data and so on. And so our really targets are, do mega instance or multi-instance in memory OLTP. Okay, Unix migration. This is probably the first platform, I would say, with Superdome X, with its reliability features and Windows SQL capabilities, you can actually make a big in-run versus Unix. Okay, this is really a time where you can actually, Windows SQL gets big enough, great enough, and can actually take on those other databases and other solutions. Okay, and this is where, as you've seen, Microsoft wants to really go. And take these things and really push the highest end here, okay? And so, like I mentioned, Maurice will talk about later, we'll actually dig into a lot of this stuff here as to how you actually use the platform, layer on SQL, and manage all this stuff and get it working. Okay, and here's some mention about what Superdome X is, kind of at a glance here. I'm not going to spend too much time here. You'll get it in your materials or whatever. Starting from a 2-socket blade, like I mentioned, and you build up the enclosure, and here's kind of what some of the features are. Okay, so you have essentially 40 I/O slots available to you, 16 socket, 12 terabytes, and a mission critical RAS and so on. This is kind of a nice at a glance. Here's what you kind of do here. Okay, and the architecture itself really brings the best out of SQL in a sense that you do need memory, CPU power, and bandwidth. You also need lots of I/O bandwidth. Okay, so you'll see that we have a balanced architecture here. If you look on the right-hand side for scaling, you will see that the bandwidth of the crossbar, which connects all the blades together, matches the bandwidth of the CPU and memory and matches the bandwidth of the I/O, which is a well-balanced system. And these numbers are far beyond what you see with any other system. They really kind of blow things away here. A couple things to note with this architecture. You see on the left-hand side there, there's the blades there, right? Like I mentioned, there's 8 blades in each system. And each blade connects to a backplane, which is a crossbar. You'll see in upper blue there. You have the blue connected to the blue there. The blue is a special chip that we use inside of HP. It's the XNC chip or Orion 2 chip. It now allows you to address 64 terabytes of memory if you want to, so we can extend to where things want to go, in the far future. And it connects to the crossbar, which then again the crossbar either can put blades together into one big partition and talk to other blades that way, or it acts as a separation mechanism between the partitions, the NPARs. Okay, and really the cool thing to note about this and why Windows SQL will do so well on this from now into the future is that the crossbar enables flat access from each blade on. Okay, so you have blade 1 being shown there, and so blade 2 through 8, which is behind it, each of those blades look the same distance away. And the distance is actually fairly close, okay? Not like some other really loose couple systems. So blade 1 has its own, you see it's 2 red CPUs there. It's a local CPU and a buddy CPU, they call it. And then you have CPUs and other blades, which are not that far away. And so SQL being NUMA aware and so on, takes advantage of the fact that, any CPU over there is within the same distance. So that's one really, really nice thing. And why we really scale really, 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 really well between 2, 4, 8, and 16 sockets if you want to build really large instances. And again, we'll talk about that a little bit later. All right, and then what I want to say, a lot of words here. Cache coherency, we really optimize cache coherency to really make it linear scaling. And this is better than any other x86 system. x86 has a situation where you have multiple CPUs getting together, and then as each CPU gets together, they snoop each other's caches and they slow each other down. And so we kind of skip all that stuff with the XNC2 chip. Okay, and this, you kind of seen this, the SQL Server architecture fits well within what we're talking about here. Okay, so what I'm going to do now is like was mentioned, I'm going to move ahead to a demo which related to scalability. So first I'm going to start with performance. So first I'm going to start with performance, setting the stage here. So HP Integrity Superdome X, okay, just blasted out everything that was there in the past. Okay. When it came out, okay? So Fujitsu machines, IBM machines, it just was 4x those machines. And then we actually beat some of the very, very largest iron. So it beat the biggest of the big iron in terms of its capabilities, okay? And so we have some spec rates there, and we have some other things there. And then even HPC workloads, we did extremely well, okay? Superdome X actually came in the number 2 single node performance out of anything, even though we weren't even trying to do that. Okay, like I said, we're special purpose built for OLTP and business intelligence and so on. We just decided to try a HPC workload because some large university wants to use Superdome X for that, and it was, again, number 2 out of 500. And they're going to buy several of these to run scientific workloads on. And so really, really interesting how based on a balanced performance, it works well for that. All right, so what I'm going to do now is we're going to move ahead to the first demo we have. And this is the this is the SQL Server scalability demo. All right, so we will.
Thank you, Ken. So my name is Laurence, and I will present the demo. So this demo is recorded, and it has been recorded. This is a joint work that we have with the Microsoft SQL Server team. So here what we want to show is the largest system running Windows SQL Server 2014. So effectively, you will see that this machine has been built with 8 blades. And you can see here the 16 sockets. There are Intel Xeon E7 V2 processors. Each of them has 15 cores. And we have turned on hyper-threading so that Windows and SQL can see 480 logical processors. So as you may know, Windows Server 2012 R2 is limited to 4 terabytes of RAM today. So even though the machine can have up to 12 terabytes, when you have a partition, you have to keep in mind that the partition cannot be greater at this time than 4 terabytes of memory. So we're running SQL Server on this machine, and there is only one instance of SQL Server. We have 4 databases, and in fact, we will put some load on the databases. So database is, in fact, a TPC scaled down database that represents 1.6 million customers and 2 terabytes in size, and it's spread across 16 disks, in fact, on the 3 par. And then we can see that we are loading SQL Server from 16 different drivers, and we are simulating 1,200 users. Of course, this demo takes some time so that the users are ramping up with the workload, but what we want to show is how the system with Windows and SQL Server is able to leverage each other. And so as, in fact, users are performing transactions, we will see that the memory fills up, and then the system is well balanced, and Windows and SQL Server are able to use all those things so that we can get with good number of transactions, good responsiveness to the users. So here are our 480 logical processors that are seen by the OS and SQL Server, and you can see that they are all used. It's balanced, and we have a steady and stable load across all those processors, because it's not, well, you know, we can scale, we can have as many processors as we can think, but the thing is, we have to have good performance. We have to have SQL Server able to use all those things so that in the end, the user will be happy with what they are doing, with the services that they are running, and in fact, the applications that they are running. So SQL Server is able to fully utilize the system. The proof of that is that we can see that the transaction continues to process at a steady state, at a steady and stable rate. So that's why, as you can see, we have 3.9 terabytes of RAM used by SQL Server. And we continue to work, as I don't know if you were in Lindsay's session, but we continue to work with the new operating systems and new SQL Server version so that it will continue to improve over time and leverage all the new features that we have with SQL Server coming up.
Great, thanks. Thank you. All right. So there's demo number 1, right? So yeah, 2 more cool demos to look forward to. So that tells you the scalability and performance, okay? So it's actually really amazing. So just some numbers really quickly. I mean, so just to kind of summarize a little bit. So this was 7.5x our previous machine that we had, a previous 8-socket machine, a DO980, okay? So incredible step in performance, and it is one of the best out there. We're actually going to have benchmarks available very soon, as was mentioned, TPC benchmarks and so on. We're running those right now. Tuning those up and so on. And so we're working on that stuff. They'll be coming out. So stay tuned for that. And this tells you 60 billion rows, right? So some of the demos shown earlier show 50 million rows and so on. You know, this is a very large machine, 60 billion rows, 16 seconds. And, you know, incredibly, and like Laurent showed, 100% CPU bound, right, all the way through. We actually able to use all the CPUs. You know, you don't see CPUs sitting around. So very good performance, very good scalability, very good ability to use everything, all the system resources for Windows SQL. And it will be amazingly even better with 16. We're doing extremely well with 14. You saw what happened. Wait till 16 happens. Okay, so next phase I'm going to move into is the flexibility portion. So what I'm going to do is kind of show another demo here. First, kind of leading it up here. So we talked about NPARs. Really important to understand NPARs. I'm going to start with a discussion on it, then we'll build some reference architectures around it a little bit later. But note that the really critical thing about NPARs is that you can actually have different instances of actually different systems. Okay, you can have different systems. So you see system A, system B, system C, hard partitions. They can actually be you guys should take them offline individually, play with them, put them back, and reboot them, and so on. And so that's really, really, really kind of nice about the aspect of the machine. Not only can you use it as one big partition, you can actually carve it up. And so what we're going to do is do a demo which shows you how you can actually use partitioning to, and show you how just how it works. Okay. All right.
So the nice thing with this system is that you can start small and then grow over time as your business grows. And here we have an enclosure that has 2 blades in it. So what we want to do is show you how you would do. So you can start with installing Windows on 1 blade because you need only 2 processors and a certain amount of memory. And then over time, as your application needs to grow, you have more data, more users who perform those transactions, then you may need more resources. And this is typical scale-out architecture. So here we see that the first partition that was created has only 1 blade. So we can see the blades. We can see that the partition is only made with 1 blade here. And then we can see the resources that you have with that blade. So you can see blade 1, socket 0, for example, here. Blade 1, socket 1, and then up to blade 1, up to 60 logical processors. Now what I want to show you is how would you grow? So over time, you have a system that's running, and it's running Windows fine with SQL Server. You need to grow it. So within the onboard administrator, which is our central management system, you just have to add the new blade into your configuration. So that can be done when the system is running. It's graphical. It could be done also through the command line interface. And then all you will have to do is reboot your system so that new resources will be taken into account. So we just reboot the system now as we have created the partition in fact, we have expanded the partition, I should say, with the second blade. And then we can see that the partition has more processors. Of course, there are 2 more sockets and the associated memory with the blade we have just added. And if I look at my management system here, then I can see that I have much more processors. So here are the blades. So blade 1 with socket 0, socket 1. And then here's blade number 3. It's in slot number 3 with socket 1 and socket 0. So it's up to 120 logical processor in this configuration. And then I can expand over time if I need more blades to be added in my system. And I can shrink as well. So I can grow, but I can also shrink if for some reason I need a smaller server. So the partition you just have to remember is the server. So you install the operating system once you have created the partition, the system is isolated. You can have other blades running over partitions, over workloads, over Windows applications.
All right, thanks. It's actually really cool to see that. You can see how you can manage now the partitions. You could have multiple workloads, each one. A lot of people actually use it like this, where they have a development system in one end, they can bring it down, they can grow it, or whatever they would need to do. Some people reboot them overnight and move blades around, and so on. So it is a capability that's been built into our Superdome class systems since year 2000, basically. And now we've brought it into x86, okay? And so it really is a kind of a capability that's been wanting in x86 and needed, because people do want the flexibility instead of big monolithic boxes and so on. Okay, so that's kind of so it's really nice you guys get to see kind of how it all works.
So that's our partitions. You can have partitions with 1 blade. You can have partitions with, so there are 2 partitions with 1 blade each, but you can have 1 partition with 2 blades, or a partition with 4 blades, or a partition with 8 blades.
Okay, so one of the things that was really new to x86, okay, is reliability. Okay. I mean, and so we work on these type of systems again for 20 years. And when we looked at x86 and we needed to bring in, needed to start running, people like Windows SQL came to us and said, we need to run our workloads on a big box, okay? But x86 is not reliable, okay? You know, not for my biggest customers. We have customers that have these certain SLAs they have to meet, okay? And so it happened also across other, you know, units and so on and so forth. And everybody did come to us and say, we need to solve this problem, okay? So what I want to do is to kind of show you in this small section here what we have done to bring x86 to the realm of mission critical. Okay, so it is as good as the mainframes. It is as good as the other boxes that have been out there a long time, the RISC EPIC boxes. And now you get this with industry standard platform, industry standard architecture. Okay, so what I'm going to do, here's kind of the top line, or the I should say the bottom line, actually, of some of the things. And we will, of course, as you guessed, end with a demo in this section. Then we'll bring in Maurice to talk about how you deploy and so on. So x86. So one of the things that we have seen and is that we have reduced downtime by 60% off the top with this architecture versus any other x86 system out there. Okay, just by doing it is down to here. Okay. And so, you know, this allows us to get to the 5 nines plus realm with x86 once you combine it with other technologies and so on. And this is just bringing the capabilities over that we've been doing for 20 years and finally bringing them over to x86. So this is actually a measured number and a strong basis in 3 to 4 years of data we've taken on x86 systems versus Superdome class systems and what we brought forward here. And also in our 1 year of having Superdome X out has been incredible. We've actually seen very good quality. People are going, wow, you know, this is amazing. They're used to x86 before. It's like, wow, I have a machine that actually stays up for a long time. Okay, and so so the expectation is being realized, I guess, with our box, which is really good. Okay, and so we will show you how some of the stuff that went into 60% downtime. You know, zero planned downtime when you put it all together. And then also we did because people are using our system for in-memory databases, okay? And we're going to be moving towards 4 to 12 terabytes of memory, then probably more later on. We had to actually do something about memory errors, okay? So tons and tons and tons of work with memory errors. And we're going to close, the last demo will be on the memory errors. And so, I mean, lots of engineering work all throughout SQL, Windows, and us, okay? To actually do things that no one else can do in terms of memory reliability. Okay, we actually do an algorithm that's better than everybody else does. Okay, because we have these large memory systems, of course. So thing to note is that this is what the whole thing looks like, right, end to end, and so you need it all to build 5 9 solutions. Okay, so in the layer in pink there really talks about the reliability of the base hardware itself. Starting from component level to the fabric itself, which we discussed, fault-tolerant fabric, firmware first architecture where the firmware grabs the error first and says, what do I do with this thing? You know, and it handles it first before the operating system sees it, and so then it coordinates with the operating system recovery. And then some of the blue areas there, you'll see how we have an error analysis engine, which we'll talk about. The Windows Server and Windows clustering adds on top of this, okay? And Windows SQL Server is critical in this, which will be shown in a minute, and how it orchestrates and how it's able to handle once it sees an error. Oh yeah, I got to deal with this without crashing the SQL instance, okay? And then you just kind of the rest of the stuff kind of piles on to get you to where you need to be, okay? So this is kind of the one slide kind of shows all. Which really demonstrates everything we've done. We've improved in every single one of these areas and brought all these to x86. All right, so all the HP firmware capabilities, library recovery and so on, HP hardware, OS, you can see down the side there, and then this is kind of nice one slide. You can kind of get a good picture of everything we've done and improved upon. Okay. We've also improved upon the philosophy itself of errors. And so generic x86 on the bottom, generally generic x86, what occurs is that it detects an error, then it says, okay, whatever, I don't know what exactly to do. Then it kind of reboots, and you don't exactly know what happens. And in fact, one demo I like to show, we have so many RAS demos. It's really cool. We have like 5 or 6 of them or something. One of them I show, shows a generic x86 machine, doesn't even know what happened. You actually put an I/O error in there, and when you looked at the logs, it showed a CPU error, for example, and you go, what? Why is a CPU error? It's a PCI error happened, and then we had to clean up and fix all that stuff with our implementation, okay? And so you see on the top level, we call mission critical x86, what we end up doing in terms of philosophy instead. We look at the error, we try to self-clean, we contain it immediately, work with the operating systems to do OS recovery. We kind of clean everything up and hand it off to them. Okay, so that's kind of how it works. Okay, so what I'm going to do then, this one big slide that shows you, oh yeah, here's all the cool stuff, memory quarantine, advanced error recovery. But it's best seen, actually, I think, in a demo, actually, is because this is really probably the best. Then if we need to go back to this, we can. So.
Thank you.
All right. So we'll show our nice.
So I have a demo that shows, again, the work that we have done. So remember, this machine is built using the machine check architecture that Intel has built. Of course, we are building the system on top of that. We are using the Intel E7 processors, which brings the more RAS capabilities. I don't know if you are familiar with the RAS name that we are using. It stands for reliability, availability, and serviceability. So all the things that we can bring into the system so that errors are tracked, they are logged, they are reported, and we try to work around them so that the system keeps up running. We avoid any data corruption. And so as this system is designed for database workloads like the decision support or the OLTP workloads where you can have a lot of resources and you can have a lot of memory, in-memory is a trend nowadays. So, of course, we have to make sure when you have a lot of memory that even though we have many hardware features that can help in solving memory errors, that in a case of you have what we call uncorrectable memory errors, they are tracked, worked around, and this work we have done was bringing some firmware enablement into our system, and then working with Microsoft, with the Windows Server team, and also with the SQL Server team, so that all the way up we have ways of working around errors, and then have the system continue to run without corrupting any data. So the demonstration that I have here is a little bit technical, but this is what we are doing at the lab. Not only we want to enable things, but we want to make sure that it works as we expect. So what we do is we have error injectors, and in this case, in this situation, we will inject a non-correctable memory error. So I just want to stop a little bit here is, we can have memory errors. Most of the time, they will be corrected. If we reach a certain threshold, then an error becomes uncorrectable. So when you have an uncorrectable memory error, any system would crash. With this architecture and with the work we have done here, when such error is detected, the firmware will act. It will track the error. It will flag the bad page, the bad memory location, then pass the information to the operating system and can pass it, which in turn can pass it to Windows Server. So here in this demo, we just have 2 blades in a partition, and this partition is running Windows Server 2012 R2 and SQL Server 2014. We want to show that, so this is running SQL Server 2014. This is the actual configuration from the Windows point of view, and you can see the different processors that are exposed to the operating system and used by the operating system in SQL Server. What we will be doing is we'll look first at what SQL Server is reporting. When I say we have worked with Microsoft, you can see that in the SQL Server error log, which tracks what happens, the different events that we have in SQL Server, you can see that the machine supports memory error recovery. SQL memory protection is enabled to recover from memory corruption. So if we have, like we have here, a database And then we look at what are the pages loaded into memory, what's in the cache for this database. So there are, this is the query which will look at the pages that corresponds to the database. And why are we doing that? It's just because I want to show you what it does when we inject a non-correctable memory error. So we just pick one page that has some data in it from the AdventureWorks database. So that's the identification of the page, and it has a virtual address, as you can see here. So of course, when we inject the error, we have to inject the error to the physical page. So we have tools that allow us to map the virtual address to the physical address, and we can see that this is really used by SQL Server at this time. It's mapped to SQL Server. And then we inject the error. So error injection at physical address here. And we will see that Windows sees that there was a machine check exception that occurred. As you can see here, machine check exception. That was corrected just because we have something in the firmware that corrects the error. In fact, it will offline the page so that it will never be used again. And from the SQL Server point of view, you can see that this page that was containing some AdventureWorks 2014 data was detected as being in error. And so SQL Server has offlined the page, so it doesn't know it anymore, and has reloaded the data in a different page. So of course, the page now is bad, and we can see in the system that we know exactly where it was, and the DIM will have to be replaced. So in fact, SQL Server continues to run. It will never use this page again, nor Windows will do. In Windows, we have track of the error. So when we will be able to service the system, we'll change the DIM that's faulty, that contains the error. So from our management system, then we can see which one is bad. And at an appropriate time, someone will probably shut down the machine, and then a customer engineer will change the bad memory DIM. So there are lots of ways to diagnose the problem. So the machine itself is built so that we track errors, we report them, and we can at any time see what happened. It's easier to diagnose any issue, and it's easier to bring the system, to keep the system running. So that was just one demo of our error recovery.
Yeah, it's really cool. Like I said, there's lots of, we're really proud of it, right? So we have a lot of demos available on our website if you want to look at them. So I'm going to head to Maurice now. I want to close my section by saying you can see how the system is the most scalable, the most highest performance system out there, right? You can look at benchmarks and see it, and you can see some bigger benchmarks coming out soon. It's also the most flexible, right? So you saw how you can partition into NPARs and so on, run Windows SQL Server instances, and then you saw all the RAS capabilities, of course. And so you can see that this is a really good platform, and perfect platform, I would say, for where Windows SQL wants to go, right? You saw the SQL's messages. We want to get bigger, more in-memory databases, okay? We want people to use databases and do instant business intelligence on them. And you can see how they would love such a platform as this. And in fact, they talk about it in their talks earlier today and so on, that this is where they want to go. And so what's going to happen here is that Maurice here is going to talk about how you build solutions on, oh yeah, good, all right. So he's going to show you how to build solutions on Superdome X using Windows SQL.
Thanks, Ken. So Ken gave us a good overview of the Superdome. So here, I'm not going to spend time on this, but just wanted, again, here's a nice summary of where we are in terms of specs. So we can see there's a great deal of power. The 12 terabytes is still, we have to wait for 2016 to take advantage of that. However, you can still certainly go up to 4 terabytes today. And the other, again, looking at the across the board on your workload profiles, you have CPU-bound type workloads, I/O-bound workloads, memory-bound workloads. So you get a very nice capacity or capability with this server to deal with these different extremes and everything in between. So you don't have to be too concerned with, okay, here we go, my workload is very CPU intensive or mine's very I/O intensive. As you grow your NPARs, all of those capabilities grow and scale linearly. So for example, a blade can have an HBA with 2 ports on the MES card, and when you scale the NPAR to 2 blades, you end up with 4 ports and so forth. So everything scales proportionately. And again, when we talk about scale up, again, what is it you want to do? So there's a fair amount of flexibility here. In terms of scaling up, I like to talk about what we call a mega instance, right? You have a 4 terabyte instance. How many people here run fairly large instances? SQL? Okay, so you can have a single monolithic instance, right? Or you can have smaller instances, or you can have a hybrid, right? And where does this come to play? Who else was on the previous talk with Lindsay this morning? The SQL deep dive? Okay. So we see a trend now where SQL is going closer and closer to running in memory. It has an in-memory engine, and more features are becoming very efficient or more efficient at working in memory, right? And so Lindsay talked about that. We have the ability now to mix workloads and not have too many concerns as it has been in the past, where you had to dedicate a server to OLTP, or you couldn't mix BI very well in that box. Or now the landscape is changing, so we can start co-hosting those different workloads. So whether it's a mega instance or you have databases that are hosted in a large instance or multiple instances within an NPAR, you have the spectrum to do that. Now, the nice thing about the NPAR, as Laurence talked about earlier, is, and we'll cover this a little bit later, is how do you port onto this machine? Well, you can port onto a small NPAR and grow it, or you can, if you're not sure what size your NPAR has to be, you provision a larger NPAR, you run your workload, you tune, and then you can certainly shrink it. You realize there's some unused processors, you're not using all of that NPAR, you can shrink it and then use the other NPARs for something else. So this is what I do. I test and develop reference architectures in our lab. I have a Superdome in my lab. I'm lucky. And right now we're working on a 16, we're going to test both, an 8-socket, 16-socket, and develop the reference architecture for OLTP. So that's, again, an example of one monolithic but large dedicated NPAR for that one or a number of OLTP databases in a single instance. Down the road, we're going to expand that reference architecture. Again, as Lindsay pointed out this morning, we want to, now is a time where you can go ahead and mix things on a large scale-up platform without having some fear that things are going to lock or not work well together. With SQL 2016, for example, analysis services now will become finally NUMA aware. So your relational engine is NUMA aware, your SSIS engine is NUMA aware, you can put them in this large platform and deploy them together, and they will play well together. That being said, we're still publishing prior to 2016 a reference architecture where we blend these different types of workloads. So I'm going to talk a little bit about how do we get on this box. You take an existing topology, an existing architecture platform, and a customer may have 10 OLTP servers or some blades. They have a BI or a reporting server. Back in the old day, when a platform would not scale with SQL, people attempted to do a scale out where they would literally use replication off to a server for reporting, right? When a small server couldn't handle all the workload, and on top of that, concurrent reporting over those tables, that's what they did. They did replication, and now the reporting tools run off of those other servers. So how do you take that topology and now move on to a much larger scale-up box? So there's a couple of different approaches to this. One of them is to take your architecture without modification and try to mimic that and bring it onto the Superdome. So let's say you have 4 servers. Well, you create 4 NPARs, and you move them over. That represents pretty low risk, but it's not the most efficient way to do it, right? Now would be a good time to look at that as you migrate and look at your topology, look at your architecture. Hey, is there something that we can change? We don't need 4 servers now. This is super powerful. So you can take that topology. Maybe it's a reporting, like I mentioned earlier. You're replicating to a reporting server. Well, you can have an availability group, but maybe you can just read off of your server that same database and not have to. You can combine. So that refactoring takes more time, takes a little bit, it's a little riskier. So, but this is one extreme, right? You just port as is. So this is the other extreme where you refactor everything. It takes a lot of planning, testing, but you go ahead and move, streamline your applications and streamline your servers and how you use them so that you're making the best use of the box. Now, center of these two extremes, again, no one says you have to do this all at once. So you can stage your migration and you can move one application at a time. Like Laurent's demoed, you can have 2 blades, 1 NPAR, move an application, test it, shrink it if it was too big, extend it if it was too small, you're happy, and then gradually you start porting your legacy applications onto the platform. So somewhere in between, I would say that's sort of a nice approach. It is going to take a little bit longer, but it minimizes your risk. So it's all about trade-offs and the complexity of your existing application. And again, with this platform, certainly you can do a failover cluster. When we talk about HA, for example, well, you can do failover clustering between 2 NPARs. And that's one model. We certainly support availability groups. Getting ahead of myself here. Nope. So right, and this is an example of when you have a report server, your legacy report server, you're doing transactional replication to it. Maybe an availability group replica is an option, and can you do it on an NPAR? When you migrate your platform as is, that would be an option for you with a minor tweak, right? Instead of using the legacy replication, you've migrated to availability groups. Okay, it's a minor transitioning step without completely re-architecting your platform. So Lindsay talked about how SQL is evolving into more efficient use of memory. And you have optimistic locking in the memory engine. All of these improvements are great. At the same time, if you've been following the Intel progression of the E7 family, we've seen improvements on the CPU as well. So the directory mode, for example, on the Superdome, when you enable that, you have less bandwidth when you use NUMA, right? The communicating between communicating with remote nodes is more efficient. So there's more bandwidth for other work that needs to take place across the QPI interconnects. So overall, we've had so many great improvements from the hardware, from SQL. Everything works in memory together. That doesn't necessarily mean you can put everything in the box and walk away and not worry about it. So you still want to have some sense of resources, and as you get onto the box, understand what's going on. So I'm going to talk a little bit about resource management from both the traditional, what exists in today in terms of SQL, in terms of hardware. From a CPU perspective, right? Again, NUMA is a great thing. In the past, it was super important because there were inefficiencies, for example, with the processors where you had to do multiple hops to get to another socket, and that's not the case now. With the E7, everything is equidistant. So when you do a remote lookup, whether it's processor 3 or processor 8, it's the same penalty. So that's already improved. The directory mode takes that a step further. So gradually, NUMA still brings you a performance improvement, right? We want to be NUMA aligned as we do our. We still want to have that NUMA alignment. If a local transaction is always going to be a little bit better now, not a lot better than it used to be in the past, but it's still better. So one of the things we want to do is we want to have NUMA alignment with our instance. Now, with SQL today, you have two ways of doing NUMA alignment. You can have the instance itself aligned to a socket, right? So if you have a mega instance, well, you can partition it to however many nodes you have in your NPAR. From a database perspective, you can have database alignment, and that's also, some people like to think about that in terms of an application alignment. So when you use, I think it's on, I'll skip ahead here. Here we go. With a port, you can align, do NUMA alignment so that your application, your session, a specific database within an instance can have alignment to a NUMA node. So these are aspects of your deployment onto a platform where you want to try to think ahead so that your databases, your instance or your database has proper NUMA alignment. And then, like I said, 2016 will bring in SSIS engine alignment as well. So in the same big 16-socket box, you can have, let's say, for example, 2 4-socket, fairly large OLTP instances, and an 8-socket SSIS instance for BI, for example. But today, even with 2014, you can do NUMA alignment on your OLTP engine, and you can do it at the instance level or at the application / database level. Again, when we talk about resources, we have to remember we look at at CPU, we look at memory, and you look at I/O. And there a couple things you know how everything is evolving, so it's hard to keep track of all of this. Well, SQL, with Windows 2012 R2, they debundled what used to be called a System Resource Manager, I believe it was called, where that was a Windows tool that allowed you to take and do throttle IOPS towards a certain LUN. And now with 2012 R2, Microsoft is advocating Hyper-V, for example, as an encapsulation that allows you to manage your resources. If you take the Superdome and you attach it to a 3-par for storage, the 3-par has priority optimization, which takes I/O resource management a little bit further than just simple LUN I/O. And so although this is a Superdome presentation, I wanted to touch on this. With this priority optimization, you can set IOP restrictions on a LUN, you can set bandwidth restrictions, or you can do both, either or. So whichever limit you hit, maybe you have a LUN set to 10,000 IOPS or 1 gigabyte per second or whatever, some bandwidth. Whatever threshold you hit first is going to activate. And it also has a concept of target latency. So you can have a priority LUN where you don't want the latency to go above 20 milliseconds. And if it does, then 3-par will start throttling lower priority workloads down so this one can have the resources it needs to maintain 20 milliseconds or better. So that's truer to QoS. So there's some interesting things there for when you move SQL to the Superdome and you have an I/O intensive application. Well, how do you want to manage that if you have to manage that? If you're close to hitting a limit on the box or on fiber channel, you have the tool to do that there. So any questions so far on resource management?
Just wondering, the cost from having information about pricing, for instance, like the one
Okay. I'll defer to Ken when I'm almost done. So, but definitely talk about that. So I think I covered the resource management. I just wanted to make sure cover the whole as much of the spectrum of getting SQL onto the box. So again, I talked about how many different ways you have of remapping your existing architecture onto the platform. That's non-trivial. And once you get to the platform, how to monitor and how to make sure you've done it in the most efficient way. And the last note on that is, as we shift more and more onto a memory-intensive type applications, we need to change our mindset. So a lot of if you've been doing this for a long time, you're always looking at IOPS, and IOPS used to be the big bottleneck and your biggest constraint. And now it's not, because everything runs in memory. So for example, if I have in the lab, I was testing this last night, I had a DL980 and I had the Superdome, 4 terabytes of RAM, and I had 4 terabytes worth of databases in there. 8 databases, 500 gigabytes apiece. And after a short period of time, maybe 20 minutes, my cache is warm, and everything was in memory. So there's almost hardly any reads from the 3-par. You could be running all day long, and you're not reading from disk. It's now all about memory page speed. How fast can you read from that DIMM? Or how, you want to be able to recover from an error. You don't want a blue screen of death. So, but it's all about that memory to disk, memory to the CPU. And so we need to think about our metrics when you monitor a system. Now, how do I grade my system? How do I compare this with something else? And a better metric, for example, is pages per second, right? Not IOPS. Ultimately, you look at, I usually recommend that you look at transactions per second or batch requests per second as a metric. It tells you how the throughput of your SQL, right, your workload, how many transactions. It doesn't matter how many IOPS. I mean, it's good to know so that you're not exceeding or taxing your box. But with these higher density memory servers, now we're looking at, okay, pages per second, what's my QPI bandwidth? For those of you who are techies, Intel has a toolkit called a PCM CPU counter. And you compile that counter, you can install it on your Windows server, and integrate those counters into perfmon. So now I can actually see what's the bandwidth to my DRAM in read, in write, what's my QPI bandwidth. So again, we shift more and more towards memory, and that's where we open the hood and we start looking to make sure things are really running efficiently. So if I turn NUMA on, I'm going to be able to measure that difference. So, Ken, final thoughts?
All right,
Here's some the numbers I have up here.
Right.
Comparing a 980 G7, which is an 8-socket server, we see about almost 8 times an increase in BI. And the test I did was 8-socket to 8-socket. So I didn't go to full 16 on the Superdome, and I doubled the increase, the same workload, 4 terabytes worth of databases. So I didn't double the number of sockets. I did go from 10 to 15 cores, but I doubled the throughput. And that is expected to go up if you scale to 16, roughly linearly. So, Ken?
All right, yeah, so we'll take some questions now. So first, visit the HP booth. There's kind of fun things going on there, and we'll be there. One of us, the 3, or, whatever, multiple, whatever. But yeah, there's fun things going on. I know they're giving away a bunch of stuff, selfie sticks or whatever, and whatever, all sorts of fun stuff. Yeah, anyway. So on your question about cost, right, because everybody sees all this stuff and they go, what does that thing cost? This looks amazing, this box, right? Okay. Yeah, okay, so to give you some idea, so there's 2 types of competitors for this, right? There's IBM Power boxes and general, like, mainframe type class. I mean, we are like less than half or way less than half, depending. It's way below. Okay, so every time we go against IBM Power, for example, on a deal, it doesn't even look like it's in the same, And then there's competitors versus other x86 boxes. Okay, so x86 boxes, x86 you can buy an 8-socket machine from several different vendors. Okay, and so as you can see from Superdome X, we can do 2, 4, 8, or 16 socket, right? And you can do 2 8 sockets in one box even, right? Because you can have 2 end partitions and have 2 8 sockets. And so against the x86 competition, there's kind of a couple levels. There's Fujitsu. Fujitsu talks about being a mission-critical x86 type box. Okay, they have some features that's better than standard, kind of standard off the shelf. Then there's some 8-socket boxes which you throw it all together and give it to you. They didn't do no work at all on any of the RAS stuff. And then they go, what's going on here? Because they didn't do any work. And so we are within the price range of the Fujitsu boxes and so on. Okay, so we see them in deals quite often. Okay. And especially when you start loading up the memory and one thing, enclosure is somewhat expensive. Enclosure has a lot of stuff built into it. But once you want to put like multiple blades in there and lots of memory in there, all of a sudden you don't see a difference, in the cost of price between the options. And then when you start putting the software on it, you don't even see the hardware anymore, And so it's not like you have to make it's not like the hardware's a big chunk of your investment anymore. And so what will happen is IBM Power would be different. They'll go in there and say, there does show as a good portion of it and so on. So yeah, you'll be surprised, especially when you start thinking about what you want to do with it. Because you got to think about, okay, I might do 2 8 sockets in there, 4 terabytes each, and you start running numbers and go, wow, this looks really good. Okay, because we do have to be competitive against other x86. So not in a different realm at all. So whoever your account team is or whatever else can help. But you'll be amazed. We have a lot of good papers on comparisons versus IBM. We also have good ones against Oracle Exadata, for example. We have. Yeah, because here's what's interesting about this is that Windows wants to, you can see what's happening here, right? Anybody can see what's happening because Windows with revision for Windows SQL 12 and 16 and having a box like this, okay, they can compete directly against Oracle, okay, and in their talks they talk about that. I don't know how much they talk about it, and so yes, we're working on comparison. Microsoft will show how you can compete directly against it. We show you how here's the application stack, what it looks like, versus running on Windows SQL stack versus Oracle stack. So yes, this is going to be a big push on that. You actually see a pretty big push on it starting in about a month. We have a lot of materials jointly we're going to be doing at Microsoft, starting right around just like early mid-June to possibly maybe July or something like that. There's a lot of material being developed around this and how you use Windows SQL to go directly against taking out. Because you can actually do it now with capabilities they have now in memory database. You can see they can now make it, and that's why that's their aspiration, as you can well tell, right? So this is the kind of platform you want to be on for that. So we've been 4 terabyte on the market since last June, okay, and then we actually did, and that was for the appliances, for HANA appliances, okay. Then December we started putting on Linux and Windows and so on in that time frame. So, but Windows 4 terabyte running Windows SQL and 4 terabyte has been since March 1st is the official release. It was listed on the Microsoft website, but we've been running it. Other customers have been running it since before that. So March 1, 2015, it was officially listed on the Microsoft website as, you can see it, Superdome X shows up there on the website as Windows certified. Windows Catalog does show Superdome X. And like I said, they are continuing to develop future capabilities on the machine using, the 12 terabyte. There's no surprise that matches, right? Hey, want to be 12 terabytes? Oh, we have a hard. It's not a by accident, right? So, because
we really have close cooperation so that they leverage our capabilities and they take advantage of our capabilities to build data systems.
Based on the presentation that you provided, it seems like very powerful machine. It works really well with server. So I assume that for the plot. Probably.
Yeah, we have been working for a long time. We started with IBM, as you know, many years ago, and then moved up.
5 minutes, that's good.
But yes, we are showing the machine, but that's a long-term work for years.
yes, right, exactly. It's been the hardware has been really kind of around for. Well, some portions of it since year 2000, in a sense, all the partitioning and so on. And then of course, the x86 portion of it is new. That comes from Intel. And then Intel had, with Ivy Bridge, they finally had enough features. We said, yes, this is finally mission critical, but we still need to build some stuff around it, quite a bit of stuff around it. And so we worked with Linux vendors, of course, and of course Windows, of course.
They always have hardware so that they can enable, and we debug and we see how things are working, how to improve, and they really improve. We and they improve.
Yeah.
Yeah, that's one thing.
Yeah, it's interesting because this machine is one of the biggest out there, and everybody first sees it and they put their stuff on and they go, whoa, because we're pushing the limits of something, and then we have to, okay, yeah. So
Hitting the limits with 8 sockets, so they want something big.
yeah, we have a couple customers that are on it right now. They're so happy. It's like, oh man, we're so throwing an instance on or whatever, and yeah.
Questions? Any more questions?
Can any of you guys speak
Yeah, yeah, Laurence is probably best for that. Yeah, go ahead. Yeah, yeah.
Right, and well, and it depends internal or external facing. And so with the situation, with a system this big, multiple instances, you could have internal facing databases and external facing databases. How would you carve this system up to satisfy a licensing requirement? Well, so does Microsoft treat this as just one giant piece of iron or individual servers?
Yeah, but you're still, for example, if you want to reduce your licensing, you're still scaling up. If you scale up to 16 sockets and you use what's called the frequency optimized CPU, which is a 6-core at 3 point something, 3.2, you still have performance because it's free. It's a database. It's sort of optimized for the database, right? And so you're still scaling up across the 16 sockets, but you're not going to the expense of the 15 core, right? So it's still, there's some trade-offs there to think about.
Right, it is. I mean, you try to offer. Yeah, I mean, we're not special in that sense. So everybody's got to do that, right? It's like, so we do offer the NPARs plus 6 core SKUs plus 10 core SKUs and different SKU sizes. We do offer the lowest one, so you can put together, you can piece things together. So, yeah, we run into the same issue, obviously.
So our strategy in environmental thinking then kind of take the support over the VMware and then do the host and then
Okay.
multiple virtual machines in it
Okay.
to install SQL Server. In that case, do you get same results or it's a significantly different than what you just install SQL on NPAR? Yeah.
But what you're talking about, we have customers doing that. VMware.
It's supported. It's supported.
It's definitely
correct.
supported, and we have customers actually doing it, and they like it. I mean, they love it. That's what they're doing. Exactly what you talked about. They looked at SQL instances in VMware.
Basically,
Yeah.
what we're saying is
Yeah.
CPU will be balanced when you have a 3-part and then make a cluster, right? And like a partition in 3 and then set it up and it will balance with the. If you have a VMware and then set it up super as a host and then put multiple virtual machines to build SQL clusters, kind of doing the same thing. Well, maybe we are losing speed on it, but maybe we can change the
All right. We just hit the time. I got the red blinking button, man.
Well, thanks so much for
Stop by the booth,
sticking
guys.
by.
If you have additional questions.
Thanks for stopping by.
All right, thanks. All right, thanks.